So we are starting off by highlighting the exponential growth equation here in the middle of all the bubbles. Now, if we're doing growth, is this going to be something that gets bigger or gets smaller? Bigger. So let's draw an example along this word growth. Whoop, there it is getting bigger. This should be increasing from left to right. We're getting into the nitty-gritty details of this function today. Compared to last time, when we had ab to the x power, what's different about this equation? What do you notice?
There's a 1 and an r and a t.
Yeah. Instead of just having a b in the parentheses, we have these details. We have 1 plus r there. This is still the b value. Oops. The b value. It's just got details shown, 1 plus r. This is still considered my growth factor because that's the number I'm going to be multiplying by every time. But if I look at the details, I have 1 plus r, where r is called the rate of growth. Now, rate of growth will be given to you in problems, in word problems, as a percentage. Anytime you put it in this equation, you're going to need it in decimal form. So we're going to have to change percents to decimals today. And if you forgot how to do that, I got you. The Dr. Pepper method is exactly what we're going to do.
Dr. Pepper.
So if you write down the initials for Dr. Pepper, that's the direction and the amount of times you have to move the decimal point to go from decimal to percentage. If I give you the decimal 0.25 and I asked for it in a percentage, you start at the decimal. Which direction are you moving the decimal point? To the right twice, because Dr. Pepper has 2 letters. This would be what percentage?
25%.
Okay. What if I gave you a percentage and I wanted the decimal? What if I gave you 5%?
To the left.
To the left, to the left.
0.2 is
So I take the decimal and I move it to the left twice. What happens when I have like a gap right there?
You put it in a place marker.
You fill in a 0. 5% is the same thing as 0.05. That's the Dr. Pepper rule. It's been a minute since we maybe turned things from decimals to percents, but we're going to have to do it today.
I knew this since I was in 5th grade.
Dr. Pepper rule. Okay. The details of exponential growth are super important. What do you notice is inside the b value? You guys said it already, but since this is growth, for growth, what do you see right here?
There's a plus sign.
Okay, that's important. That's going to come in handy a lot today, that if you know your graph should be growing or increasing, there's going to be a plus sign. Now let's go talk about what Kayla was talking about. Down at the bottom of this page, what do you notice here?
It's decaying.
It's decaying. So is this one going to be getting bigger? No. Decay graphs are going to decrease from left to right or get smaller. What do you notice is different about this equation from the run above it?
It's got a negative.
It's got a minus sign in the middle. So instead of 1 plus r, you've got 1 minus r because it's going down. It is called the rate of decay. Very good. If it was rate of growth for the growth formula, it's going to be rate of decay for the decay formula, but you still need it in decimal form. So we're still going to have to use the Dr. Pepper method. Again, the b did not change. That's still my variable that's in the parentheses. I'm just seeing the details of that factor. Anytime you're given a rate, like a percentage, it is not the number that goes in the parentheses by itself. It has to be in the details. So today when I give you percentages, don't just stick them in there. You have to make it the percentage, which means that it is the r. You do 1 minus or plus r. Now some examples, hold on. So some examples about decay. I'm going to show you a YouTube video. Is if anybody gets squeamish easily, just close your eyes, okay? So other things that decay include human bodies. Have you ever watched like CSI or any of those detective shows where when the detectives show up, a crime scene investigator is like, the time of death was 3 days ago between the hours of 9:30 and 12:30. And they're like, wow, how do you know that? Yeah, because they do math. The science behind forensic science is actually a mathematical equation. If you know how quickly human bodies decay, You can find a human body that's decaying, work backwards, and figure out when it started decaying. Gross, but cool. Okay? So we're talking about things that actually exist in real life today. I hope you enjoy it, and I hope you find it entertaining today.
No.
Now, we're going to have to be able to tell the difference between an exponential function that is growth and an exponential function that is decay. I already wrote this on here for you, but I didn't write it on my own. For a growth equation, if we just see the equation, we don't see the graph, how might I be able to tell that it's growth? It has a plus sign in it, just from the equation, not from the graph. Or, what's another way from the equation I can tell? For growth. There should be another way I can tell about growth. If you see the plus sign, or if the b value is bigger than 1. Because if I have a plus sign, not the r, the b, which is 1 plus r. If my 1 plus r is bigger than 1, that means I had a plus sign in there. So it has to be a growth equation. How do you think I'm going to be able to tell its decay from the equation itself?
B less than 1.
If you physically see the minus sign in there in the details, or if you notice that the b value is less than 1, the number in parentheses is less than 1. Now, if I'm given a picture of a graph, how will I know if it's growth? What will it look like if it's growth? It will be above the asymptote. Both of these will be, because these are real life examples, but it will be going up away from it. What would decay look like?
It'll be going down.
It'd be decreasing from left to right. Still above the asymptote, because these are our real life scenarios. On the inside, we have a question that asks you to identify the function as growth or decay, then sketch the function. Identify the initial amount A and the rate of growth or decay R. Is it asking me for B at any point here? No, it's asking me for the rate, which you give to me as a percentage. Did it ask me to graph the function accurately?
Yes.
No, what word did it use right here?
Sketch.
Sketch. Sketch is an estimation. As long as you have the initial value and whether it's increasing or decreasing, I'm good with the sketch.
Okay.
On this first one, f of t equal to 475 times 0.45 to the t. Is this growth or decay? Just looking at the equation.
Decay.
How do you know it's decay?
It's less than 1.
It's less.
What's less than 1?
The B value. The B.
The b value is less than 1, so this is a decay formula. Awesome. What's the initial value?
475.
How do you know it's 475?
Because it's in front of the parentheses, which is A.
Absolutely. Does everyone see how the first number in that formula is 475? That makes it my initial value as well as my y-intercept. Tell me where 475 is. It's not labeled on this graph. You get to pick it. I'm picking right there. That's where it's going to cross the y-axis. And I need to make sure, bless you, make sure that this is a decay function. Can I cross 0? No, because it's called the what?
Asymptote.
Asymptote.
No touch line.
The I'm not touching you line.
Yeah, that thing.
Don't touch me, fool.
Yeah. All right. The R is a little bit difficult to find, so just put your pencils down and watch what I do. The R for decay, the things in parentheses, should it be 1 plus R or 1 minus R?
One minus.
Decay?
Minus.
It's minus.
It's subtracting if it's decay. So this R is going to be 1 plus something equal to 0.45. Because the parentheses number has to be equal to 1. I just put a plus sign.
Yeah.
1 minus something equal to 0.45. My bad. Bless you. Okay, we need to now play a fun game of who can figure out what goes in that box. One minus, the rate does go in that box, but what number would go in there?
0.45.
Try it. If you think it's 0.65, in your calculator, I want you to do 1 minus 0.65, and hopefully it's 0.45.
Miss 65.
Do it.
Did it in her head.
Check it in your calculator.
Where you get 65?
No.
Does that one work?
No, it does not.
It does not work, so let's try another one.
55?
Let's try 55. Is 0.55 the thing that should go in that box?
Who knows?
Yes.
1 minus 0.55, which we throw in our calculator and check out,
0.45.
is equal to 0.45.
I got it.
0.55 would be the number that I need to put in that box for it to work. 1 minus 0.55 is equal to the number that I got in the B. That R value in the box is how I answer this part. But I answer it as a percentage. So what is 0.55 as a percentage?
55%.
55%. That's the rate that this particular function is decaying at. So again, the number in the parentheses, unless you see the plus or minus sign, is not your rate. You have to find it. It's in the details. If we look at the second equation, h of t equal to 12 times 1.05 to the raised to the t power.
That's growth.
It's growth. How do we know it's growth?
Because more than one.
Because it's more than
Because what's more than one?
The
B.
The b. The stuff in parentheses, the b. The factor is bigger than 1, so it's going to be growth. What's my initial value?
12.
12 or 5?
12.
12. So give me a 12. Doesn't matter where you put it as long as you give me a 12 for this sketch. Remember, we're just sketching. If I ever ask you to graph, you do need to be accurate. Now we want this to grow. So we sketch it growing. Y'all already told me that the initial value, or A, is 12. But now we need to find the rate. We have to look at the details.
1 plus equals
1 plus something, good, equals.
1.05.
What do I have to add to 1 to get 1.05?
0.05.
Absolutely. So 0.05 is what goes in that box. But you answer rates as percentages. 5%. This is a weird idea
Yes.
because they give you the B, what I'm going to be calling a simplified version, where they've already done the adding or subtracting. You have to work backwards. For decay, you know that it's going to be 1 minus something. And for growth, you know it's going to be 1 plus something. You have to figure out what goes in that box to tell me the rate. So if they're asking you for the rate, you've got to work backwards into the details. Questions, or do you think you guys could be able to try number 3?
No.
No.
You know it's not smart enough for that.
Nope.
What if I got you started on it?
Yeah.
Because you're all looking at this and going, Miss Quigley, there are no parentheses.
Well, yes, there is.
There are.
But
The number that's in parentheses, is it the one with the T attached to it or the one without the T attached?
the one with the T.
Okay, so you're saying that the 1.8 really should be the thing in parentheses.
Yeah.
So that's my B value.
Yes.
What's my A value here?
1.
How do you know it's 1?
Because it's invisible.
Because it's invisible. If I left you here, would you be able to attempt this one for me?
Yeah.
All right, you got it.
I got it done.
Based on the formula that you see, 1 times 1.8 to the T, is this growth or decay?
Growth.
Say again now.
Growth.
Growth. This is a growth equation because that B value is bigger than 1. What's my initial value here?
1.
1, because it was the invisible 1, so we're going to make that be right here. And we said this one should grow. So your sketch should look something like that. Is that what your sketch looks like?
Yeah.
Beautiful. Now to find the R, we have to get into the details. You guys told me this is growth, so it's going to be 1 plus something equal to 1.8.
0.8.
0.8 goes in that box.
Let me move it 2 times.
We move it 2 times to make the percentage. It's 80%.
Period.
Because this would be moved 2 times, and any empty number you fill in with a 0. That's 80%. This next one is in table format. You should still be able to tell me growth or decay.
Maybe that's what growth is growth.
Looks like decay.
It's growth. It's decay.
It's
Because it's going down, miss.
All right, look at the Y values.
It's decay.
Okay, because the numbers are going lower.
The numbers are going lower. from 256 to 64 to 16 to 4. So this is going to be a decay formula. It should be going down. Based on this table, what's my initial value?
256.
How do y'all know it's 256?
Did I
Is that a
start
zero?
at the y-intercept?
It's the y-intercept. It's partnered with 0, which means that's where this graph is going to begin. That's my initial value at 256. So we give ourselves a 256. I'm going to make mine right here. And this should be decaying.
Yes.
Now, here's the challenging part. I could totally go to Desmos, like Kayla is suggesting, type all this in and get a regression equation so I could see the R. But that's a lot of work for something you can do if you know your numbers. Can anybody look at that table and tell me how those Y's are changing?
It's going down.
It's going down.
Be more specific. How is it going down?
1 minus something. Little by little.
I heard someone say it. It's dividing by 4 every time. Do y'all see that?
No.
256 divided by 4 is 64. 64 divided by 4 is 16. 16 divided by 4 is 4. What would be the next number? Oop. 1. 4 divided by 4 is 1. Okay? Which means that this is using a fraction of 1/4. Dividing by 4 is the same as 1/4. So when we fill in this rate formula for the details, we're going to be doing 1 minus something equal to 1/4. But everybody's looking at me like, Miss Quigley, y'all know I don't like fractions. Y'all know I love fractions, but I'll help you out today. What is 1/4 as a decimal?
25%.
25.
What's 25%?
Or 0.25. So
No,
what
1/4?
what do I put in that box?
Right, they need to go to school.
1? Oh, it'll be 0.5. No,
Me too.
it'll be
1 minus 0.2 is 0.25?
Oh, minus. Oh. Yeah, I don't know.
What would go in that box, y'all?
1 minus something equals 0.25?
You're not wrong.
1.
0.75. Thank you, Abby. 0.75.
Why?
That's counting corners, Dan.
That's what I'm talking about. Know your monies, know your quarters, know your numbers. So what percentage is this decreasing every time?
75%.
Oh.
75% rate of decay. So whether I give you a table or an equation or a graph, you should be able to figure out the R and the A. We're going to practice to be able to tell me the R and the A.
But Miss, can we still use Desmos?
You totally could have used Desmos. You could have totally put this in Desmos, done the Y1 squiggly line AB to the X1, and seen that they gave you a 4th starting at 256. They would have given you exactly that. Now, we're going to move on to a different kind of question. If you are lost on 1 through 4, when we stop doing this and I move you to your classwork, you're going to come see me and we're going to go over it again. Deal? Deal. All right. On number 5 and 6, I need you to be able to write these functions from a word problem. Okay, this is what our classwork is going to be about today. It says that we want to write a function f of t that represents the situations below. All we need to fill in is the formula f of t equal to whatever a is, open parentheses 1 plus or minus whatever r is to the t power. There's 3 things you're going to be filling in from a word problem when it comes to growth or decay. You need to figure out where we started, if we're going to grow or decay, and what the rate is as a decimal. So we read this first part. It says, in 2005, there were 100 rabbits in Polygon Park. The population increased by 11% each year. What does 100 rabbits represent?
Y-intercept.
Our y-intercept or RA. Very good. So 100 goes right there. Is this going to be a growth or a decay formula?
Growth.
How do you know it's growth?
Because it says increase.
Because it says increase. So am I going to use plus or minus?
Plus.
Plus. I need a rate.
0.11.
11%.
So 0.11, which is 11%, goes in there. Raise it to the t power. Y'all, this is an acceptable answer for me. But I'll tell you right now, the test makers will probably not give you this as an answer choice. they're going to simplify it. They're going to get rid of the details and make it one number in your parentheses.
0.11.
So what they will do is they will take this parentheses right here, okay, this parentheses right here, and they're going to actually do the addition or subtraction problem. So
1.11.
1 plus 0.11 is
1.11.
1.11. So you might see answer choices that are 100, open parentheses, 1.11 to the t. That's like literally the same thing as what we wrote down. It's just without the details. Y'all know how in the problems 1 through 4 we had one number in our parentheses and we had to figure out what the r was? This is like the backwards version. I gave you the details in this one, but this one put the details into one number. Does that make sense? Prove it makes sense. You've got number 6. I want you to write me the equation in both forms with the details and in the simplified version. Cool? If we read this question, it says a $900 sound system decreases in value by 9% each year. What is the 900?
The initial value.
What does decreases tell me I'm going to do?
Go and subtract it.
Negative.
Which is growth or decay.
Decay.
Okay.
And what is this 9%?
Your rate.
Your rate. Now, when you change this to a decimal, should be 0.09. Did y'all do that part right?
Yes.
Sometimes I forget to move it twice, and then I try to use 0.9, and it's different. 0.09, you got to move it twice. Dr. Pepper has 2 letters, so you move it twice. Here's what I would have done. I want to fill in f of t equal to the a value.
That's an X.
LOL, you right. Come on, Miss Quigley. F of t equal to a, open parentheses, 1, either plus or minus the r, close parentheses to the t. But you guys already told me that it's going to be 900 to begin with. Huh?
Why'd you put a plus?
Oh, I was just telling you the regular version with both options. In this one, I'm putting a minus because it's decaying. Y'all told me that, right? And then 0.09 goes here to the t power. That's an acceptable answer, but how will the test writers maybe write it?
900 0.09 t.
91%.
1 minus 0.09 is 0.91. This might be how you see it on tests. It'll help me know it's decaying because it's going down. Those of you who got this or got close, how do we feel?
I feel proud because I got it all right.
Good job.
Everybody there.
Did you get that? Or did you fix it to that? Okay. How they have been written on the STAR test in the past, where they're going to give you a scenario, maybe give you the equation, and then ask you to tell me a bunch of things about the scenario. Scenario number 7 says, consider the function, and we highlight this functions because that's important, y equals 24 times 0.5 to the x, where y represents the number of teams left in a baseball tournament after x rounds. The first bullet point says, the initial number of teams in the tournament was blank. What was the initial number of teams in this tournament?
24.
How do we know that?
Because it is in front of
Because
the
that's
parentheses.
Because
the
it's the A equals 24. If we graphed this, that would also be the y-intercept, where we begin. Second sentence says the number of teams blank over time. Does it increase or decrease?
It decreases because it's less than 1.
Because B is less than 1. Very good. Because that's the number in the parentheses. If the number in the parentheses is less than 1, it's decreasing. Last little bubble says the number of teams left after 3 rounds is blank. If it's telling me 3 rounds,
What do we 0.5?
3 times 3 times 3. That's the A.
so what does the rounds represent?
Oh, you rounded to the nearest.
Oh, not rounding. I get why you said that. It says where y represents the number of teams left in a baseball tournament after x rounds.
So it's X.
So it's x. So this question is asking me to figure out what 24 times 0.5 raised to the 3rd power is. I want to know what happens after 3 rounds. I see some people already grabbing their calculator. You can use Desmos to calculate or your calculator. 24 times
It's 3.
It's 3.
Okay, I didn't multiply.
After the first round, there would be 12 teams. After the second round, there would be 6 teams. After the third round, there would be
24.
Totally.
3.
24.
Let's talk about Penelope. Number 8. Penelope opened a bank account. And this is legitimately how savings bank accounts work. So if you don't know how bank accounts work, this is how they work. Penelope opened a bank account where she can earn compound interest. The initial deposit was put in the account and no additional deposits or withdrawals were ever made. She put the money there and she didn't touch it. She just gave it to the bank.
She wants money.
The balance in her account can be modeled by the function, we highlight, S of t equal to 500 times 1.015 to the t power, where t represents years. Okay. How much money did she initially put into her account?
500.
500. Because why?
Because A equals 500.
Very good. Will her balance in her account increase or decrease?
Increase because B is greater than 1.
It will increase because b is greater than 1. That's the number in the parentheses. It's only barely bigger than 1, but it is bigger than 1. That's also how savings accounts work. You tell a bank, hey bank, hold on to my $500. The bank's going to say, cool, I'll give you money for doing that. Let's figure out the rate that she got from this bank to see if it was a good deal. The rate that the bank changes, the rate that the balance changes each year is, well, you guys told me that this was growth. The rate is not the same thing as the B. So am I going to do 1 plus or 1 minus?
1 plus.
1 plus something, that rate is equal to 1.015.
Oh, 0.015. So
0.015.
So 1.5%.
Now we're both in the same problem.
1.5%.
So we move the decimal twice, and we would get 1.5%. That's how her rate changes each year. She got a 1.5% account, which is actually pretty dang good.
It is real.
Yeah.
How much is it?
The balance in her account at the end of 3 years is blank. So if we want to figure out, without her doing anything to that money but giving it to the bank and telling the bank, hey, hold this, how much money will be in her account after that? What number am I plugging into this formula? 3. Paul can't take all the money, so we're going to figure out how much is in her bank still. We're going to do 500 times 1.015 to the third power.
And then you put in kick.
522.
3.
83.
Yeah, some people earlier asked me, Miss Quigley, how do we round? If you're dealing with money, round it like money to 2 decimals. So without doing anything, Penelope gave the bank $500, said, hold this. At the end of 3 years, the bank said, thank you for letting us hold this. Here's $22.83 extra. You can have it back as well as your $500. That's how savings accounts work. You want to put your money in with an interest rate that's really good. The bank gives you money for leaving your money there.
Sounds like a pyramid.
It's not a pyramid scheme, it's banking.
Sure.
It's like a
It's
lot.
a
Don't they all say?
It's like free money. It's passive a way to make your money. Now, investment accounts where you take risky investments, not a savings account, those will give you back more money quicker, but you also could lose your money. A savings account, you won't ever lose your money because it's just being like held there, being saved there. Let's see how we do with Antonio. Antonio bought an iPhone and he's trying to sell it back. Can you guys answer all of the questions for Antonio on number 9? No. Give it a shot. You got it. Let's go. 2 years ago, Antonio bought a new iPhone. He now wants to sell the iPhone for what it's worth so he can upgrade. This is legitimate information. I Google this every year to make sure that this data is still correct. I had to update it from last year to make sure it was still accurate. So if you're trying to sell back your phones, this is for real. Okay. The phone's value can be modeled by this function, P of x equal to 725.99 times 0.4 to the x. What was the initial cost of the phone?
$725.99.
because A is equal to 725.99. Very good. Is the phone going to increase or decrease in value?
Decrease.
Decrease. 1, because we know that when you try to sell back your technology, you can never sell it back for as much. Technology decreases over time. Also, because B is less than 1. Now here's where I got a bunch of questions. The rate is not 40%. That's your B value. Remember, for a decreasing function, your B value is 1 minus the rate. So what would I have to put in that box for my rate to make that math sentence make sense?
0.96.
0.6 is what I put in that box. And 0.6 as a percentage is, move it twice, 1, 2, 60%. So please remember that the number in the parentheses is not your rate. You have to find it. Now, Antonio tries to sell his phone after 2 years. We want to see what $725.99 at 60% decrease for 2 years would be. How much can he sell it back for?
$116.15. Wait, what?
16. It was like 1.58, so we'd round to 16. But yes, that's why you can never sell back your stuff. If you keep it for 2 years, it's not really worth as much as it was before. Y'all ever try to sell back a phone and get really mad when they give you like $5?
Yeah.
That's because this happens. Technology depreciates over time or decreases over time. Just like a car.
God dang it, man.
I know. Spend your money on things that aren't worth it. Except they are, because you use them. Okay, here's what we're going to do to practice. We're going to practice, go ahead, Paul. We're going to practice writing equations and evaluating them. On the page that says, would you rather, by the way, glue this in your spiral. Make sure you bring it back next time. You'll be very happy you do. On the page that says, would you rather, you're going to use that equation I wrote on your paper for you. Y equals A times 1 plus R to the X. To decide which of these 6 situations your table would choose. So far, I've not had any group pick the right answer. The group that picks the correct answer, that gives them the most bang for their buck at the end, I will give 2 quick bucks to each. Okay? The first one says you will receive a one-time payment of $20,000. So for the first one, you get $20,000.
This A.
Yeah, no, obviously.
For the second one, it says you put $5,000 in an account for 10 years at Ally Bank's rate of 1.90. Here's the principal. That's the initial value. We're always going to be increasing because we're saving money. I have a rate of 1.90%, which is what decimal?
0.90.
It's 0.0019.
Just 1 0. 0.0190. That's my rate. And how many years am I doing this?
10.
So what are you going to plug in for X?
10.
10. I want you and your group, in the next 10 minutes, I'm going to put on a timer to decide which one of these scenarios, A through F, is the best one. Put your name on the top of the page. When you reach a consensus, you fill out the bottom that says we chose or I chose this because. And if at the end of 10 minutes your group picks the best deal, I've made you the best investors, I'll give you 2 quick bucks. Do you accept the challenge?
Yeah.
Go for it. You got it.